to work a couple of problems out with the long division. On page 28. Okay? Now on page 28, I just had you guys work on two problems, right? Problems number 4 and 5 here in class. Problem number 4 is going to look like this. 2a plus b, then 4a to the third plus 2a squared b minus 2ab squared minus b to the third. Now, we're not going to need to reorder the terms in my dividend here because all the terms are in the proper order. How can I tell that? I'll look at my divisor, the lead term, 2a, all right? When I look at all the other a terms in the expression, the lead term of my dividend is already written with the highest exponent on the lead term in terms of a, is expressed first there. So what I'm going to do is just leave this the way it is. Only problem number 3 is you have to rearrange the order of the terms to make the division work. So I'm going to say 2a divided into 4a to the third. Lead term of the divisor into the lead term of the dividend. And that is going to give me, as most of you guys already got, 2a squared. You take the 2a squared and you multiply it by both terms of my divisor. And that's going to give me, not 2, but 4a to the third plus 2a squared b. Now, this is long division. So what do we do here? Don't stop with this and combine your terms. You have to subtract. They all do cancel, right? So what I'm going to do now, bring down the next two terms of my dividend, minus 2ab to the second, minus b to the third, right? 2a will divide into a negative 2ab to the second. And if you're not sure what any of these expressions are going to become, let me do an example here. If I want to see what goes next to the 2a squared up here in my answer, I'm going to look at the negative 2a b to the second, the lead term of my partial dividend, divided by the lead term of my divisor. What is this? What does that simplify to? It simplifies to a negative. Don't forget the negative though. Negative b squared. So that's what goes here. Okay? And I could have done the same thing with the 2a into 4a to the third to get the lead term to begin with. What is that going to evaluate to? Reduce to 2a squared, right? And that's where the first 2a squared came from up here in my answer. All right, now, minus b squared times 2a. I've got to multiply this part of my answer times the divisor. Place it up underneath my partial dividend here. Negative b squared times 2a. Negative 2a b squared. Negative b squared times a positive b. Negative b to the third. Subtract, which means the signs are going to change. Everything's going to cancel out. My answer is here. You should have done all that. If you didn't do all that, you didn't get the answer. If you got the answer, Tiffany's smart.
No, because we work it out together. Maybe we work it out together.
All right, come on.
I do know.
All right, let's go to number 5. All right, number 5, x minus y. Okay, let's look at this one here. All right. This is our problem, x minus y divided into x to the fourth minus 4x to the third y plus 6x squared y squared. You see the rest of it, right?
Yeah.
So, all right, let's divide. Get the first part of our answer. We're going to look at x to the fourth over x. Reduces to x to the third, right? Okay. Now, x to the third times x minus y is the next step. That's going to give me x to the fourth times a negative y, negative x to the third y. Subtract. The x to the fourth will cancel. Have y'all noticed this pattern in all these long division problems? All these first terms always cancel. It's going to be key to understanding synthetic division here in a little bit. Where we get to today or more. Now, this minus here is going to change the negative x to the third y to a positive. And then what am I going to get? Negative 3. Don't forget the negative here, right? Bring down the next term. Why are we only attacking the dividend in this problem 2 terms at a time? Because the divisor is only 2 terms long, right? Keep that in mind. If this were 3 terms long, I'd be working 3 terms at a time. Okay? All right. Now, to get the next part of my answer, I'm going to have to divide negative 3x to the third y by the lead term of my divisor, x again. And what is that going to give me here? Negative 3x squared y, right? Y'all see that? Negative 3x squared y. Now I multiply negative 3x squared y times x minus y. Negative 3x to the third y. Negative times a negative is going to be plus, right? 3x squared y squared. Now, common mistake, careless mistake would be not to put parentheses around here, add the 6 and the 3 and get 9 here. That's not going to happen. Subtract. That's a negative. The first terms cancel, right? That's a negative 3 and a positive 6. Positive 3x squared y squared, right? Bring down the negative 4xy to the third. 4 at the next. Y to the third. I don't feel like trying to write it like smartboard tonight. Okay. Yeah, so we're saying x into 3x squared y squared. What is that going to give us? 3xy squared, right? So that's going to give me plus 3xy squared. 3xy squared times x. 3x squared y squared again. 3xy squared times a negative y. 3x y to the third. Subtract. Lead terms cancel. That becomes a positive 3. Negative 4. Negative x y to the third. Bring down my last term. Finally, y to the 4. Okay? I know it's great fun, isn't it? X into a negative xy to the third. Dividing here. That should give you a negative what? What are we looking at here? Negative x y to the third over x. Negative y to the third, right? Okay. So, negative y to the third times x. Negative x y to the third. And then a negative y to the third times a negative y. Negative times a negative is a what? Positive. And I like this problem too because there's no remainder. You know? So that's it. So that makes this my answer. Okay? That's my answer here.